Yeah, that's recording. We're good.
All right, Dave Jenkins here with my
Eddie Mercado.
Eddie Mercado. So we're going to go over our observation that we did last week and get right into it. So, Mr. Mercado, if you can, just first thing you wanted me to look at when we did a little bit of our pre-observation stuff was what was causing the frustrations of the students. So I have some things that I'll go over with you with that. But what did you teach in the lesson, and what were the students going to accomplish in the lesson?
The students were supposed to learn some coding basics so that hopefully they could apply that learning to a project that they're working on. Some of the students are interested in bringing a robot to life, and they know the mechanical side of things. They can put it together and take care of the assembly, but they don't know how to actually control the functionality of the robot with input. So the coding was intended to provide them with a background to be able to help them get started with that task.
Okay. What did you notice about student behavior during the lesson?
Okay. I think generally speaking, I saw that there was a lot of students, not a lot of students. I'd say about 50% of the students saw the learning as being unnecessary because they didn't want to do coding. They want to build. They want to be designers. And they didn't see where coding fit into that overall plan. So I think some of the frustration that I was seeing was directly related to a lack of interest and a lack of utility that the students perceived in the actual task. They just didn't see it as purposeful.
Okay. All right. Now, reflect on the lesson a little bit. What do you think went well during the lesson?
I think that what went well was there was a very concrete objective. The kids were supposed to create a little program that was a very simplified version of creating ASCII art. So they were supposed to design a little face. They weren't told how to design their face, but they were given all the tools to write the code that would eventually allow them to print something to the screen. So there was creative flexibility in the sense that they weren't being told to just follow these directions to achieve a specific outcome. And then there was also something that was very practical being demonstrated or being taught, because it was showing them directly how through code you can make something happen.
Okay. What do you think were some of the easy parts for the students to pick up?
They all seem to be pretty familiar with the keyboarding nature of trying to code. I would say that they understand how a command ultimately leads to some kind of function in the computer. So that cause and effect seemed to be something that the students were grasping.
Okay. All right. From just my perspective, looking at some things, also relating it back to Iowa teaching standards, a couple of things I thought you did a really nice job of hitting on, just aligning it with the student and building and district goals. Some of the things we talk about with using technology, and we have, coding days and everything that way. So I thought you did a great job with that. Relaying the information across content area. Obviously, with coding, you're getting into math and everything else, and so letting it go cross-curricular there. Some of the technology, obviously we're using the computers, which with us being a one-to-one school, that's something we want to see. And then the other nice thing was with you and Mr. Olson working together, I also saw that component of you working collaboratively with other staff. Other areas and just data points, there was 5 different times I noticed that you and Mr. Olson stopped during the class and walked around to everyone's computers, looked at their computers, made sure everyone was on the right page. That first day I was in there, because we broke it up into 2 days, there was a lot of struggle just finding their document because they hadn't saved it correctly, and so finding that. But many times you guys were right there. I think that was one. I've seen you do that multiple times now that I've been in the classroom, but also I think the fact that you had 2 teachers in there was nice with that. And so those are some of the areas of strengths that I noticed. What about some of the challenges? What were some of the challenges? You mentioned earlier maybe the lack of perceived interest just because they didn't see how it might be beneficial to them. What were some other things that you noticed that were challenging?
Actually, there's one specific challenge that rises to the top of something that I learned a really valuable lesson in finding this out. I've come to find out that one of the young ladies, the only lady in the class, Haley, she came from a family situation where they kind of lived out in off-grid. Like, they didn't have any technology. So I came in operating, we're a one-to-one school. I assumed every single student knew how, when at the end of a,
Save
command,
and boom.
return.
Yeah.
Just even little things like saving a file, double-clicking on an icon to open up a piece of software. She had no idea. And that I was operating under this assumption she had these basic skills. I come to find out that she needed some very specific direct instruction. And I assumed that she was being lazy, that she wasn't necessarily wanting to work hard, but she didn't know what to do.
Gotcha.
So she was trying to multitask to actually catch up to where the other people were.
And do what they were doing.
And do what they were doing at the same time. So what I thought was, I made a false assumption. And as we dove deeper in that, Haley pulled me aside and was like, hey, you may not know this about me. And I was just kind of dumbfounded. So that was one thing that I clearly shouldn't jump to conclusions about student readiness, especially when it comes to a task that's as complicated as writing code. So then the second thing that I know that was a challenge was when we started to collaborate, the timing of Mr. Olson's availability versus my own availability, it was better for him to have the students come to his classroom. And I didn't even really think the first time that we were going to interact, I had a sub. And I didn't tell the sub, take the kids to Mr. Olson. So they sat in there waiting for like 10, 15 minutes for Mr. Olson to show up. Mr. Olson was in his room waiting for the kids to show up.
Okay.
And because I chose to not be specific about the directions, I made assumptions about people's understanding of my sub-plans without taking care of that really simple, fundamental piece of data that the sub was going to need. Like, where the hell do I take these kids? So the kids ultimately told him, I think Mr. Olson's supposed to be here. So I think I didn't think through some of the practical needs of that sub when I did that plan. And that made me rethink the next plan. That I wanted to make sure that that didn't happen again, no matter whether I was here or not. So I wrote some stuff down that I probably wouldn't have tried to put to paper if that first situation hadn't played out. So that was a learning experience.
What were ways that you assessed their learning at the end? I know you said they had to create a face with one of them. What were some of the ways you kind of assessed that?
The easiest one, did their program run? So that was a real concrete objective. So run your program. Oh, something's not working. So fail. No, I shouldn't have said fail, but I just mean like they weren't able to accomplish the task. But the other thing that I noticed is, like you mentioned, just even finding the file to go from previous work that was done to the current work that was supposed to be accomplished. There were some students that didn't know how to actually find the work because it was a piece of software they were unfamiliar with. So I think that maybe exposing them to the software beforehand, before we even started instruction, like we downloaded BlueJ, the software they were using, the very day they were supposed to start using it. In hindsight, I probably should have had that on their computer and ready to go. People should have known what the software was going to be used for. I think I would have done that a little differently second time.
Are there any other programs similar to BlueJ that you're familiar with?
Yeah, there's the one that we use for our robotics class is way more complicated. It's nothing but you type. BlueJ is nice because it's got some like drag and drop features. You can build code with blocks that are predefined. So when you drag a block, that code isn't necessarily noticeable, but it's there. And you can look at it if you want, or you can just hide it. So it's a little bit more efficient to try to assemble a program. But in terms of building readiness for my class, which is what this was really intended to do, they're not even going to use that tool.
Yeah.
So I think in hindsight, I'd also like to decide how am I going to create some readiness for the piece of software that they actually use in my class. So we could have collaborated on that a little bit more effectively, I think, beforehand.
Okay. One of the things that I noticed, and this just came up when we were talking, is from standards and criteria, but understanding the developmental needs background. So going back to the young lady that kind of was off the grid, didn't understand that stuff. So that was just one of the areas I had wrote down for improvement, and taking notes here. I'll also be writing down some of those communication pieces and maybe even putting down using a different software, one that might be more conducive to the learning that you're going to do.
Or at least more practical for the outcomes that will be expected of them if they choose to keep doing this work.
Yeah. And so, once again, I'll give you a copy of all this stuff at the end, and you'll have a copy. Other things that I thought maybe you could do with the Blue Jay, I know you guys designed a face, and you had some autonomy in choosing what the face would look like. But what if there were other tasks that they could do rather than a face, maybe a sports logo or ball or something that way? Maybe just a little bit more freedom there. Maybe that would perk their interest just a little bit. Other areas that I was looking around, like the hour of code, I think some of our kids are familiar. I don't know how that would carry over to your other projects in robotics. And then there's also a website with a blog of 15 ways to teach student coding. And so that's some of the information I put in here that you'll get afterwards. Is there anything, and you've kind of touched on this, anything you might do differently? So you touched on maybe use a different software, communicate a little bit there. So is there anything besides those that you might change?
I'm definitely going to be considering turning this class into something that freshmen cannot take. I was a little disappointed in their overall understanding of technology. This is supposed to be a class that's an introduction to robotics, and given the nature of some of the engineering design processes, I've never had this many freshmen. They're all freshmen, 10 freshmen, so that's the max capacity of the class, 10. That they were 10 freshmen has proven to be a real challenge. That's probably another thing that I could list as a challenge, and it's actually made me rethink whether it's appropriate to have our incoming freshmen. Maybe it's that the only freshmen that can take this class are freshmen that are formally identified as TAG, or have a teacher recommendation from maybe Mrs. Smith that might be familiar with what their capabilities are at the middle school level. That I think I need to rethink who is going to be allowed to take the class. And complicating that is Mr. Olson had hoped that this class might eventually become a preparatory step for his introduction to programming.
Okay.
And so if I was going to do that, then they wouldn't take the class until they were sophomores, potentially, and then that would diminish the time they would have available to maybe take Mr. Olson's class. So I'm not 100% sold on that yet. I would want to talk to Mr. Olson after we have a chance to kind of evaluate how the lesson went overall.
So from an administrator standpoint, for myself, we just mentioned a little bit about maybe changing some of the prerequisites for the class. Are there any other supports you would need from me with this class? I mean, that sounds like a pretty good one, maybe a discussion we need to have here in the near future with Mr. Olson and yourself and I.
I think also one of the things that's really problematic when the kids start working on putting new software on their computer, we continue to use this filtration software that limits what the kids can do with their machine. So when I tell them that they need to install a piece of software, we have to kind of set some things up before they can do that. And I realize that we can't. It slows down the process. And I've also I'm of the opinion that it makes the students feel like we don't trust them if we're going to assume that every time they have access to their computer, they're going to try to learn how to build bombs or to surf porn. So, in my opinion, I think we need to find some happy medium that allows them more freedom to have some administrative access to their machine, while at the same time providing parents with the level of security that they need to know that their kids aren't going to use their machines inappropriately. There's got to be a fine line that we can walk there. I'm just not sure where it is.
All right. Well, that kind of concludes everything. As I said, I've got copies that I'll get to you,
Okay.
and then we'll use this information go forward and
Okay.
have some of those conversations.
Okay, all right. Thanks a lot.
Thank you.